Neo4j is a graph database. So naturally, I'm geared towards thinking about everything as graphs. And I'm going to tell you why you should too. So we had this idea that relationships are the key things to understanding data, and that data on its own is kind of useless. The interesting part about data is how datums relate to other datums, how pieces of data relate to other pieces of data. The relationships in data is central to that data. It's the same thing with humans, that we understand things by how it's connected to other things. So we understand things by relating them to things we already know, for example. When we learn, that's how we learn things. There's research showing this. So for example, we can understand a new software venture by saying that, by describing it by what it's like. And you see these kind of things all over the place. People describe new products by what it's like and how it differs. So we relate it to some existing thing. It's a relationship that's important. And I remember from my childhood when I was learning what East and West was. I had this realization in the kitchen that it's like left and right, only on the earth instead of on me. So I related it to something I knew. And other things are graphs too. Like, these are examples of how we relate things to things we already know. And as I said, there's research showing this. This guy, Roger Selye, said in a paper in 1981, which is some time ago, that the deep approach, and he was talking about learning, is one in which students seek an understanding of the meaning of what they are studying related to previous knowledge and interact actively with the material. And he was claiming that this leads to a better retention of what you've learned, as opposed to just studying answers to the questions that you think will be in the test, which students tend to forget afterwards, whereas where they relate to the previous knowledge, they get a deeper learning experience. And just like other things are understood in their relation to things they relate to, this research called Learning, Approach and Outcome, some empirical observations, is related to other things. It cites other papers. So it's related in a graph to other papers. It's a graph of papers. So if you want to learn more about what Roger had in his mind when he developed the ideas in that paper, you can read the papers that he cited and gain a deeper insight from that. Or with modern indexing catalogs, you can also do reverse citing lookup and find papers that cite Roger to find what other people are have discovered since, which is quite a powerful thing. And I like, for example, this thing, where Canon Walker, a few years later, says that if the brain works primarily with key concepts in an interlinked and integrated manners, our nodes and word relations should, in many instances, be structured this way. So they're pretty much saying that if our brain works by relating things to one another, we should also structure our data to relate things to one another, which is exactly what we're doing with the graph. And we can look at an example of linked data for text documents, for example. So if you've got a body of text on the internet, there are multiple connected things. I mean, text is something that looks very unconnected and not very related to things. But actually, there are links to other text. That's a connection, like in hypertext, for example, on the internet. You might also have comments, proposal, and proposals for improvement and stuff like that people have added to your page. For example, comments on blog posts, or if you're running a wiki. If you've ever looked at the discussion pages on Wikipedia, there's a whole lot of related data to the page, and that's also it's related. It's a connected thing. And of course, links to supporting research. What is it that backs the things that you claim in your text? Just like Roger in the example before had cited other papers. But you can also look at things like user behavior. How does your user interact with your text? Even if it's just text, you still have a browser that will visit the page, and you can derive behavior from that. And you can see from that, you can get all kinds of interesting analysis, like where did they come from? How did they reach your page? Did they enter an address? Did they click a link? Where did they click the link on? How long did they stay on the page? Did they search to get to the page? And what pages did they visit in your website before they got to that particular page? You might do surveys on your web page and see, did they find what they were looking for? Or maybe you have some smart algorithm for realizing that yes, they stayed on this page for a while, they scrolled around, meaning they probably read it, and then they left your domain completely. So yes, they're either they were completely disappointed after having read through it all, or they were satisfied and didn't need to read anything more. You can figure that out from where they went next. If they went back to a search engine, maybe they weren't happy. If they closed the browser, then maybe they were happy. Or you can do surveys. And all this is data related to the page. Yeah, click, click, click. So even something as blobby and seemingly unconnected as text, it turns out that once you look at what other things surround it, actually there's quite a few things connected to just something as simple as text. And of course there are many, many other examples of connected data, such as a mind map, which you see an example of on this slide. Or the structure of a document. This was one example that I did in the politics domain a few years ago when we were drafting documents for processes or something, I don't remember, and making alterations to this, and all the finished documents was a basic document and then a bunch of documents detailing the changes to the original document or to the changed documents. There was never a final artifact, or there was in the end, but while we were working on it, it was just a base proposal and then alteration proposals to it. And it was a real mess to keep track of what part of each document that the alteration proposals were talking about. So I found that structuring that as a graph helped me a lot with understanding what the hell we were talking about. But of course there's, we talked about behavior as in the user behavior of this example, but you also have other types of behavior, like purchasing behavior on a shopping site that many companies use for deriving things like recommendations. And of course the classic example of when talking about graph, which is classical because it's so obviously a graph to everyone, of social, where you've got people who are friends with other people. You've got in pretty much all modern social network sites, you've got the concept of liking things, which they use for recommending new content to you. Like your friends like, many of your friends like this, you might like it as well. Or many people who like this also like this. Many people who like these things that you like also like this, so you might like this as well. And also sharing of website. All of this is connected data. Even this presentation is connected. Connects through the flow of how I go through this presentation. And I even made when I created it, I drew it as a graph on a whiteboard. And then laid it out so that I could get a natural flow through it. And I had my basic ideas on what I wanted to get out of it as a mind map, which is also a graph again.
Do you have some kind of critical path or so you work through?
When I create presentations in general?
Well, when you draw your graph and then you make a presentation, now you have to know where shall I start, what shall I do next, and so on. Do you have some kind of critical path or something you walk through?
No, not really. What I did was I wrote, as you see here, I started with index cards, and I had all my ideas on various index cards, and then I laid them out in order, and then found, okay, then I want to go back to here, and reshuffled and shuffled again until I found something that kind of worked for me. So I just focused on getting a flow through it. That is an interesting question, not really related to the topic, but very interesting anyhow. I don't know, it's gut feeling, I guess. Does this feel good? But back to the topic at hand of graph databases. So a graph database such as Neo4j is a database that stores data as a graph. And we've seen examples of graphs. And a graph is made up of nodes and relationships. And the relationships are the things that connect the nodes. It's the interesting part, like how are nodes connected? Nodes are just are entities or pieces of fact. And the relationships is the interesting part of how these things interconnect. Both nodes and relationships have properties, and properties are just simple key-value pairs that describe these entities. Like it describes if a node represents a person, it describes things about that person, such as that person's name or birth date. I don't know what you want to store about a person. Gender, maybe, yeah. If you care about that sort of thing. If you're building a dating site where you match up people by the what gender of people they prefer dating with, then that might be interesting information to store. Yes. The relationships that relate the nodes, that connect them to one another, have a type that describes how they are related. Like if two people are friends, they are connected by a friend relationship, for example. Or could be. You can name these types whatever you want, but naming them something that is helpful to you. For finding nodes, we have a concept called labels that now allows you to sub-select a group of nodes and searching through that group, so that if you can have a person label on a node in order to be able to distinguish people from things like companies, because both a person and a company can have a name. So being able to say, I want to find a person whose name is Tobias is something you can do by saying, I want to find something with a person with the label person and the name Tobias, rather than just I want to find anything with the name Tobias. And then I also need to figure out if it's a person or a company or whatever. But the label concept helps with that grouping. So it's type denomination for typing thing for nodes. Okay, so we got this data, but data in isolation is completely uninteresting. The interesting parts come when you query the data. So we got a query language for Neo4j called Cypher, and it's like SQL but for graphs. So again, we understand what it is by relating it to something else. And it's like SQL in that it does selection of things, it does projection of the data into a results format, and it does aggregation such as summing up things or collecting things into a collection or taking the average of something. But it's for graphs in that the way that the primary way of which we query data is by matching patterns over the graph rather than joining tables together.
Is Cypher unique to Neo?
It is, yes. There are other groups who have implemented similar things to Cypher for their systems, and they've been eagerly telling us that we should standardize Cypher so that they can implement the standard. I still think that it's not. We might be getting where we could where we could standardize the first version, but I still think that there are so many things we still want to evolve with the language. There are a few things that aren't perfect yet, or although perfect is never where you get to, but they aren't good enough yet that I think it's premature for standardization. That's my opinion. But yes, it's something that it's a language that we have developed. So this pattern matching on a graph is done by you draw an example of a pattern that you're looking for, and then the database will find matching occurrences of that pattern. So essentially, it's query by example. You draw an example of what you want to find, and the database finds things that matches that example. And when I say draw, of course you have to express this in text, because text is how we interact with computers in programming languages. So when I say draw, I mean ASCII art. So you essentially draw that nodes are names encircled in round parentheses, and then dashes denote relationships between them, and then you can add square brackets to specialize those relationships. So you can say that I want this to be a relationship of type nos. So should this be? And I also want this relationship to be a likes relationship, and so should this. So in this example, we're modeling this pattern here, where I want to find friends of my friends who like the same things that I do, and whom I don't already know. So I'm finding my friend, my friend, and the people that they know from 1 to 2 steps away. 1 to 2. That's the friends of my friends. I'm also looking for...
Friends of my friends, and potentially them.
Yes, potentially their friends. So 2 to 3 steps removed from me. That have an interest, they like something, that I call an interest here, that I also like. But where I don't already know that person. And this will give me, the result of this will be a list of those friends of friends, the friend I know them through, and the interests that we share. Okay, so why? I'm going to take a step back and look at modeling in general, and an example of that I think has been used many times in relational databases. That I think is an anti-pattern that you see a lot all over the place. That I think will help me with making the point that that a graph is a better model for a database. So, and it's the one of where you have an entity with lots of optional attributes. So you don't know. So there are many things that you can potentially store about that entity, but in most cases, most of those fields are going to be null, or you're not going to have that information. So you might be storing information about a person. It may or may not have a Twitter handle. It may or may not have a website. It might have a favorite fish. I don't know what these means. They're just silly icons. Might have an address. May not have an address. I might be homeless. I might be doing a register of mostly homeless people. And the way that you see this modeled many times in a relational database is through what's called an entity attribute value table, where you've got one table that stores the actual entity, like the core things, the things that the table contains the things that I know about all entities, and then another table with just the attributes for that entity, the optional attributes. Selected by, categorized or something by the name of that attribute. So you store the attribute and its value for the entity in that table. This is quite good for when you find the entity through some means, and then you just want to find all the attributes for that entity. If you want to go the other way around, however, it's not ideal. So what people end up doing instead then is saying that, okay, I want to be able to index this, and this isn't very indexable because it'll lead to a secondary index on that table, or it might be a composite index. It'll lead to a composite index. That's what it'll lead to. Where if I want to find the everything that has the name Tobias, for example, that will be a composite index lookup, which is typically inefficient. So what people end up doing instead is that they break out into multiple tables, one for each attribute, and you end up with just with multiple entity value tables for each attribute. That allows you to separately index each one of them. And this is called a column database. Congratulations, you just invented one in your relational database. Which is kind of a bad idea, because you weren't setting out to build your own database. You should not be focusing on how to store your data. That should be the job of the database. You should focus on what data you're interested in. And the database should be doing the job of figuring out how to best store that for you. So I'd claim that the relational model is a bit of a blunt tool for storing data, and that more modern databases might have an edge here in terms of making it easier for the user to deal with their data. So in a graph database, the graph is the model. Everything is a graph. The way that you interact with the database, you're just thinking about the graph. And then the database takes care of representing that graph in the most efficient way possible. And since it's mostly us in the room, I'm going to say that we're not there yet. We're making good progress, But there's so many things, so many exciting things that we can do to make this even better. I think that we got the model working fairly well, and we do represent it in a good way where we can make more things under the hood to specialize storage in ways that you don't have to think about. All of this allows you to focus on just your domain and not have to worry about how data is stored. You just model your data as a graph. And why graph then? Well, if you think about how you model data, like the tools you use for modeling a domain, those are tools such as ER diagrams if you're working with a relational database, or UML if you're working with object-oriented models. And if you look at these two types of models, it turns out that they're graphs. So the tools that we use for modeling our system, our data in for other systems that aren't graphs, the tools we use are graphs already. So why do we go through that extra step of translating our data model just to be able to store it? Why not have a model that allows us to store data closer to the way that we think about it? And this is an example I've been running for I don't know how many years, and all of these people who have done presentations have stolen it from me at one point or another. Maybe not all of them, but many people have stolen this example from me. And it's a good example. So that's a good thing that they do. It's one of writing a blogging service, something like Blogger, where you have users who are members of blogs. A user can be a member of one or more blogs. Perhaps the same blog can have more than one user that is a member of it. Each entry has one author, which is a user. So a user writes an entry and then publishes it onto a blog. Then you can also have comments commented on entries that are also written by users. You got this domain and kind of drawn on a model. You can draw the model for this domain like this. And the beauty of using a graph here for representing your model is that you're done. You don't have to do any other extra translation steps through some ER lowering process, or whatever it's called. It's been so long that I've done those things. I've just worked with graphs for the past 10 years. You just store that data exactly like that. So you have nodes representing these different users, and you have nodes representing the blogs that they can post on. And you got nodes representing the entries that they've written, and relationship representing where they were posted. You got relationships representing the users that wrote the posts. And you've got relationships relating the comments on entries to the entries that they are comments on. And of course, I haven't written out the types of these relationships because that would have been a lot of text in the same slide, and it would have been completely unreadable. Instead, I've colored them, which I think should be good enough. But the beauty of this is that you got these different concepts of how things relate, and it serves different purposes. So you got the content and where it's located, but you also manage users and access control in the same graph in a very natural way. The access control being which blogs is the user allowed to post entries to. So you see that the relationships between these data items is the sort of key driver behind everything. So it's a shame it would be a shame to remove the relationship. So instead, having a graph that lifts the relationships to the first class as a first class entity is a good thing, I think.
Do you have a real world example where you actually run a big blog this way?
Not a blog in particular, no. People aren't making money off of that. So there aren't a lot of...
Medium uses Neo4j.
Do they?
Yeah.
Medium, yes, they do. I don't know what they use it for, but...
It's a big blog engine, something,
Oh.
Neo4j.
Okay.
Recommendations, they send out in emails. The recommendation, the medium recommendation emails.
All right.
So they,
It's like
they
work.
model all of this stuff in Medium in order to do their recommendation.
All right. Good that we got all these people in here that know things that I don't know.
What was reference? Medium?
Medium, yes, medium.com.
They set some medium logging engine. Yeah, nice.
Meet up member of Vixis.
Achievements unlocks.
It's a website where people write.
Yeah.
Centralized write blogs and they try
Yeah.
to recommend you other things that might be interesting to you.
For you to read, yeah.
I just meant if this is so good, all big blogs should be done this way.
They should, yes. But all the big blogs were written before they knew about Neo4j. Because they all run, or not Medium, obviously, but a lot of blogs out there run on WordPress, which is an old blogging system, written in PHP. And if you ever read the source code for it, you will cry.
So there's a good chance it will be the new engine for blogs.
If I wanted to do that,
Maybe.
although this is a very optimistic picture in that it shows me authoring a majority of these posts, and I don't author many posts at all. So I'm not, since I don't write many blog posts myself, I shouldn't be, I should probably not be building a system for publishing such things. But someone else, feel free to steal my ideas and implement this for real.
You're just the idea man.
I'm just the idea man, yeah. And I don't believe in ideas having some sort of value in their own. So I'm very, very, very happy with someone stealing my ideas.
Again, the very big guys like Facebook and Twitter and LinkedIn,
Yep.
they do NoSQL.
They do use NoSQL databases. The ones you mentioned don't use Neo4j, do they?
Facebook uses Neo4j.
Do they? For
Build system.
something?
But they use the graph. I mean, the point of to be something all about the graph modeling.
Yeah.
And Facebook is all
Facebook is all about graph.
They use the word graph all the time.
Yeah.
That stuff.
So does Twitter.
So the Google Knowledge Graph, the Facebook
Social.
graph,
Social graph.
graph
Graph search.
graph search is a big thing they talk about. It's a very similar model in use.
But they've, to some degree, built their own purpose-built systems. Facebook has a very unique use case that means that pretty much nothing existing works for them. They built their own hardware, their own software, in order to support their load. I'd like to think that that you could run Facebook on Neo4j, at least someday. I know that we've got customers that input all of the connection data from Facebook into Neo4j, so you can at least run all of the social aspects of it in Neo4j, and they do keep up with that. So that does work. Of course, it doesn't deal with all of the things that these users do, like posting things and liking things and sharing things. Those things they don't import into Neo4j. But we've got customers that import all the social into Neo4j. So one thing that I've been thinking about lately, and I've been thinking about this because I haven't been building things on top of Neo4j for a while. And it would be interesting to see how, it would be interesting to try that again. Because because the model has changed since last I actually used it, and the model we have is a lot better these days than what it was 7 years ago when I was a user. And back then I used to structure my data such that to tailor structure it for the queries to a much larger extent than I would today, because for performance reasons it was required. But with the updated model, especially with labels added, that helps me find things without structure. The structure of the graph can be focused on the actual structure of the domain. And I know that, so I don't think I would need to optimize my model for my queries as much anymore as I used to. And I know that I've done, when I worked with other databases, I've done this more than I've done with Neo4j, of optimizing my model for my queries. And I'd like to do some brainstorming around that at some point. Am I rambling now? Your face looked confused, but maybe that's the way it always looks.
Certainly if you're talking to us or the other stuff.
So the reason you would the hell? The reasons you would want to optimize your is that
Get out.
Sounds bad. Just remove
the doorstop maybe?
maybe look at that.
That fixed it. That unfixed it. I turned the lights off. Someone will have to edit this movie because this part is not very good. Okay. So the reasons you would want to optimize your model for your queries is that, of course, it's fast for those queries. And since you've created your model from the queries that you know that you're going to need, you will not store data that you don't need to store. Whereas if you try to create a model that is all-encompassing, or tries to be very close to the real world of what you're modeling, because models is just models of the real world. You might end up storing things that you're not actually interested in. Although you might be interested in it in the future. The drawbacks of having something that's heavily optimized for your queries is that when you add things in the future, you might have to rethink some of those optimizations. They might not be valid anymore. It might also lead to redundancy in your data, and I've seen this particular in relational databases or other databases where you do a lot of denormalization, and you have to have a lot of code in your application to deal with keeping these duplicate data entries up to date. And I like how Neo4j and graph databases in general solve that by by having relationships be bidirectional, so that you can always traverse relationships in both directions. So you can have not only, so if you have a likes relationship between me and, or a node representing me and a node representing pickled herring, you will not just be able to find out that I like pickled herring, but you will also be able to find all the people who like pickled herring. One of them would be me. Why did I use that as an example? That's a weird example. Another drawback of having things, well, I said that it becomes hard to change and update your domain as you find that you need to support new queries.
One question. If you don't optimize for your queries, is there a risk that you don't get a decent response time?
So I think that there's a good answer to that, and that is you should benchmark and optimize when you find that you need to optimize. So you would, I think the way I would model things today if I were a user, I would think about what the natural way to structure my data would be, and then try all my queries. If they don't perform well enough, I'd look at, okay, what kind of support structure would I need? How would I need to restructure the data to better be able to suit those queries? And if and when I find something, I would think about, okay, so this might change my model. How does it change my model? How will I be able to evolve those things over time?
But you think about always, you know the user and exactly what is out there. This model, the great thing with the graph is that you can ask questions you didn't know you had.
Absolutely, absolutely.
And then if the risk is too big that you get the database locked, in that case you also can allow a longer response time,
of course you could, yeah. That is a good benefit, that having a rich model such as the graph allows you to ask questions to it that you didn't know ahead of time, and usually that works well. And I wouldn't say that you'd get problems with long blockaging, because the database is, at least Neo4j, is really good at handling concurrent requests, in particular read requests. And of course, you can write queries that'll do things that'll by necessity of how the query is, what the query is trying to do, will do things in a suboptimal way, such as looking at all the nodes in the entire graph 5 times over. Finally, in the most recent version of Neo4j, we have good tools for analyzing what the query plan will look like, what the database will actually do in order to solve your queries, and you can use that for finding out why something is not performing the way you thought it would, instead of just sitting there wondering if it'll ever finish. But great that we're having these conversations, because this is a conversation I wanted to have. But as I said, I was mainly going to focus on why you would use a graph database, and leave the how to the conversation after, and to me and all of my colleagues who are half of the people in this room. But there's also going to be great talks on that if you go to London in May. So I'm going to do a plug for that. We're running a conference in May 7th mainly, but also a tutorial day on May 6th. Or training day, we call it. in London that I highly recommend, and I think we've got discount codes as well if you're not interested in, or if you're interested but not really willing to pay those prices. Although you would be paying more for travel than you would for the ticket probably. I don't know what the price was. I didn't look at that. And yeah, as I said, everything is a graph, even this presentation. And that's all I wanted to say. Or that's all I had prepared to say.